Alrighty. So moving on to the next skill that was in their extra credit assignment is dividing unit fractions and whole numbers. And this, I think, is where lots of kids are confused. And the reason they're confused is because they don't really understand what's happening. What I want to caution you against doing, though, is teaching them the keep, change, flip. They're going to learn that in 6th grade. The goal of dividing unit fractions and whole numbers in 5th grade is for them to understand the concept so that when their teacher next year explains keep, change, flip, it makes sense. So please, I really caution against showing them this, where you keep it, you change the sign, and then you flip it, because they don't understand what's happening with the math there. They know how to get an answer, but in a real world situation, which is a word problem, which is how this standard is assessed, they're not going to be able to pull that out of the word problem. And so what's important here is for them to understand what's going on, which is why in 5th grade, we only work with unit fractions. And so unit fractions are fractions that have a numerator of a 1. So this could be an example of like 1/2, 1/5, 1/8. That way, they can draw these models to understand what's happening when you take a whole number and divide it by a unit fraction. Or if you take a unit fraction and you divide it by a whole number. This is where the models are important, because in a real world context, in a word problem, lots of them just do stuff with the numbers and they don't try to make sense of it. So our models are here to help us. And so we've actually learned 2 different ways that we could show this thinking. You can do something called a tape diagram. You can also do an area model. And so in 3 divided by 1/2, in division you always start with the whole and you're dividing it into parts. So we're going to show the whole first. I'm going to show in my tape that the whole is 3. I'm also going to show in my area model that the whole is 3. And so in my model, right now, I can see each of these wholes that I do have. Now, if we were to continue this in the tape, we want to take every whole that we have, so all 3 of them, and we want to divide them in half. And so then the question is, well, how many halves did I just create? If I count all of them together, we just created 6 halves, which is the answer. This is how many halves are in 3 wholes. For some kids, like drawing all of this is confusing because they are partitioning the same direction twice. So for some kids, an area model is more efficient because then if they just divide what they already have into half, now I have 6 units, which is my answer. Again, if you teach them keep, change, flip, this doesn't explain to them what's happening in the situation. It's like in a real world situation, they could label what the whole was. They can label what the part is and try to make sense of what's happening. Whereas if you just teach them keep, change, flip, they don't have a strategy for a real world situation other than hoping that they pulled the right number sentence out. Now, on the opposite way of thinking, if you started with part of something, meaning the whole in this case is 1/2, and I am trying to partition it into 3 parts, this tape's going to look a little bit different. My area model is going to look a little bit different. We're actually going to show the 1/2 that we do have with some shading. So I don't have the full whole, I only have half of it. And I can see that thinking represented in both of these models. I can see that I'm only starting with half. And what I want to do with each of these halves that I have, I want to divide it into 3 parts. So this half that I already have, I want to partition it into 3 parts. Now the problem with the tape is that I can't show different size units. So here I have 3 parts showed, or I'm showing 3 parts. I have to do the same thing to this part of the half, even though it's not here because it was originally part of my whole. And so when I do that, I created 6 parts like I did here. However, the 3 shaded units out of 6 is not my answer. I'm going to explain why in a second. If I were using the area model to show this thinking, I then just split it into 3 parts. And for a lot of kids, the area model is a lot easier to show this thinking on because they only have to divide it into 3 parts once. Whereas in the tape, they have to do it twice. So if they're struggling with this, try to show them the area model. And y'all, we've been practicing this in class for weeks. It's a lot of thinking, which is why I think they're overwhelmed with it. But like the models are there to help them understand what's happening in the problem. And so earlier I was saying 3/6 is not the answer. The way that you think of this is I always put a context to it. If I had half of a cake that I cut into 3 pieces, what would the size of each piece be? Each piece wouldn't be 3/6. Each piece is going to be 1/6. So this is where I have the kids go back and they will double shade what their final answer is, which is one of these units. Because a lot of them keep their answer as 3/6, but they don't realize that each of them are not 3/6. Each of them are 1/6, like the size of the units themselves. And so again, the models are here for when they have word problems. And the reason that we practice these without word problems is so that when they get to a word problem, they've already had practice drawing the tape or the area model that matches the thinking in that word problem. Realistically though, like if they just see this on a test where it says half divided by 3, if they know how to solve it, they get the points for it. But in a word problem, they have to be able to pull this out of it. And unfortunately, in a word problem, they don't just get this. And so that's where the models come in. It's to help them slow down their thinking in a word problem and not just doing stuff with the numbers because that's what they think they need to do.